So here a Huffman question which they are given the number of character and its frequency. So first of all, it can be built the many heap. So we can be draw the tree, and the tree must satisfy their many properties. So we can be do the heapy phase. So now see the root value is a minimum value compared to the all other character in that trees. Now we can be delete the root of the tree. After we can be delete the root of the tree, we must do the rightmost of the leaf can be go to a root, go to the root. So there we also check their heapify properties. So we are deleting the 0 comma z comma 2. After we can be replace that place with the t comma 16, so that is affect the mini property. So we can be do the heapify. After heapify we can be get this tree. So now we are also deleting root. We delete the root. Here s comma n can be go to the root, so that also affect the many property. So we can be do the heapify. After heapify we can be get this tree. So now we can be deleted the two root, so we can merge these two root. We can be get g comma r comma 4. So now we can be merge these into the this tree. So this side we can be merge this. We can be merge the any new leaf in the minute. Always it is merged into left to right. So now we can be do the delete the root. Before we delete the root, we can be check the many property. So it is affect we can be do the heapify. After heapify, now we can be deleting the root of the tree. After we delete this root, this can be go to replaced, so that affect the many property. So we can be do the heapify. After heapify we can be get this tree. So now the same procedure, we can be delete the root, and these can be go to a root, so that also affect a many property. So we can be do the heapify method. Now there is a two nodes can be present, so we can be merge these. We can be get n comma g comma r comma 7. So here these can be added into the exiting tree. Here it is added. After we can be delete this root. After we delete this root, these can be replaced there. That also affect the many property. So we can be do the heapify. So here after heapified, so now the same procedure, we can be delete a root, then we can be merge these two. After merging these two, we can be add these merged leaf node into the exiting tree. After put this same procedure, we can be deleting a root. Then we can be replace these leaf node into the root node. Then do the many then check the many property is satisfied or not. If satisfied, do nothing. If it is not satisfied, can we affect that property, like we do the heapify. So here also we can be do it. So now the same, we can be delete a root, then the rightmost can be replaced. Also we can be doing the heapify, like likewise we can be doing here. Until we can be get a complete tree, we can be doing this like a procedure is you can be build the mini tree, and we can delete a root, and we replace that place into the rightmost leaf node. After check the mini property. If it is satisfied, do nothing. If it is not satisfied, then we can be do the heapify methods. Then checking that the root value is always less than the all other nodes values. Likewise the parent is always less than their child nodes. If two of the root node is left, which means it is deleted, then we can be merge these two, then we can be add these new leaf node into the exiting tree and do the same process until the tree of all the node can be, until we can be do it, the tree is all the leaf node can be involved in that process. So after we can be doing this, we can be get this tree. After we can be doing, we can be get this tree. So it is the final tree. After we can be get this tree, we can be put zeros the left of the trees and we can be put 1 at the right of those trees. So here it is the root and we can be put zeros at the left and 1 in their right. After putting it, we can be do the write the encode of the bit. So here the question, the characters and they can be given the frequencies. So we can be write the encoded bit for those of these frequencies. Like if T, here it is T, so we can be reach 1 0 and H, here H, so it is reached so 0 1 1 and I, so where is I here, so 0 0 1 and S, so 1 1 0, then A, so 1 1 1, then R, it is 0 1 1, no 0 1 0 1 1 and N here, so 0 1 0 0, then G, it is 0 1 0 1 0, then space 0 0 0. After we can be get the encoded bit, we can be check it is the prefix free or not. So here we can be see 1 0 1, the other starting of the bit in 1 is this and this, but after starting is 0, so these two are different, and after it is 0 and this one, so it is not in same, so it is a prefix free. And also we can be write the prefix encoded bit for this string, so this is a string. Then T we can be get 1 0 and H we can be get 0 1 1, I we can be get 0 1 1. Likewise we can be write the bit for that strings. So here we notice that higher frequency of the character can be have a lower bit, because the T have a frequency is 16, here we have 1 0. So that's all.